Hey, I'm Alec, and today I'm going to talk about the top 10 advanced upgrades for your 3D printer. Before we get started, be sure to watch our previous video, Top 10 Upgrades for Your 3D Printer, since those dive into some of the more basic and simpler upgrades to install on your printer, whereas this one's going to go into ones that are going to require a bit more setup to get running. Now let's get to it. 3D printing in the enclosure is done for the purpose of keeping a controlled environment of air temperature around a progressing 3D print, which is hugely important for high temperature materials that you're 3D printing. But because you have the enclosure there, any heatsink fan you have is just going to be pushing more warm air onto an already warm heatsink. So you're not going to be doing much cooling there. To help with that problem, E3D has the Titan Aqua, the liquid-cooled Chimera, and the liquid-cooled Cyclops. And because they're liquid-cooled, that moves the air temperature out of the equation completely. For direct drive 3D printing, you have the Titan Aqua. For dual extrusion multi-material printing, you have the liquid-cooled Chimera. And for dual color but same material 3D printing, you have the liquid-cooled Cyclops. For these three systems, the same method is used to help keep them cool. There is a pump and radiator outside the system, which means that you can have a much larger fan to cool down the liquid, which also means it's going to be much quieter than the same fan that you would normally have on your heatsink. So liquid is pumped out of the pump into the hot end where it takes in the heat, pumps it back out into the radiator, cools it back down, and through the system it goes. Most 3D printers come stock with an 8-bit controller board that drives the whole motion system. And that works on most machines, but for some there's some serious lag as it tries to calculate how the whole machine has to move with such a small microprocessor. Upgrading to a 32-bit microprocessor is a huge upgrade in your printer's calculating abilities, which means that prints can be faster or quieter depending on which motor drivers you have on them. The PainterCat Aztec X5 GT, the Aztec X5 Mini Wi-Fi, and the Duet Wi-Fi are all 32-bit processors that are great at what they do. The Duet Wi-Fi is an all-inclusive package with integrated TMC 2660 stepper drivers for quiet motion, it has Wi-Fi control, and it has plenty of expansion opportunities. The Aztec X5 GT or the Aztec X5 Mini both don't come with stepper drivers, and as such the price of them is lower than the Duet Wi-Fi. So you can pick and choose exactly which stepper drivers you want for each motor, or you can upgrade down the line later to something different. No matter which of these three boards you choose, you're still going to have to do some major tinkering to get your printer up and running. Whereas most 3D printers run off of the Marlin firmware, these three run off of either SmoothieWare or RepRap firmware. So there is going to be some converting you're going to need to do with making sure that all of your printer's values from before are translated over to the new firmware language. If you want to head with the PainterCat Aztec X5 GT or the Aztec X5 Mini Wi-Fi, or you already have a printer board that you can swap out stepper drivers, then PainterCat has some stepper drivers for you. The BSD 2660s use the same TMC 2660s as mentioned before, and these use the Bigfoot profile. The Bigfoot BSD 2660s use the TMC 2660 driver on these boards, and they only fit on the X5 GT, because they have a bigger footprint to handle the higher current loads, hence the name Bigfoot. The larger footprint does mean you can put more current into these stepper drivers, so you can have faster and more precise movements, like most 3D printers have a 1/16th microstepping for the motion systems, while the BSD 2660s have 1/256th. For boards that only take these smaller Pololu-style stepper drivers, the SD2224s are hands down my favorite stepper driver. With the right jumper placement, you can have these have 1/32nd microstepping and enable Stealth Chop 2 for virtually silent 3D printing. I can be in the same room as my printer with these drivers and not hear it at all. Despite being such a small accessory, bed adhesives play a huge role in the success of your 3D prints. And while PVA glue and hairspray does work well, PVA glue can leave a residue on the bottom of your prints, and hairspray is hard to apply in a controlled fashion, so you may just end up with a fine mist across the entire inside of your 3D printer. Advanced bed adhesives like Magic Glue help with that significantly, because they have a couple different formulations intended for different materials. They have a base model for PLA, ABS, or PETG, they have one for polypropylene, or nylon, or polycarbonate. But the way they work is that you apply them onto your bed just the same way you'd apply a glue stick. You want to make sure you're using glass. And as it heats up, prints will bond to it really well. But as soon as it cools down, you can just take the print off the bed without needing any sort of spatula or removal tool to get the print off of the printer. 3D GLOOP is another bed adhesive that has some impressive properties. As an adhesive alone, you can apply it to the build plate just as you would any other, whether using the brushtop version or the squeeze tube version, and you can even print ABS on an unheated glass build plate, although they do recommend at least 60 degrees Celsius, which is still unheard of for printing ABS. And not only is it a bed adhesive, it is also a print adhesive. So whether using the PLA, ABS, or other formulation, you can apply that to one part and some to the mating surface on the other part, stick them together, and give them some time to dry, and they will be bonded basically forever. At this point, what it's doing is it is chemically dissolving those surfaces of the two parts, and then as it's evaporating away, it is bonding those two together so they are one part. It's like trying to separate a print along the layers. It's really hard to do. High temperature printing not only requires a change to your hardware to be able to reach those temperatures, you also need to change some of your thermistors to be able to accurately measure those temperatures. A standard thermistor maxes out at about 280 degrees Celsius or 300 degrees Celsius. But the E3D PT100 sensor or the MOSQUITO thermistor can reach 400 degrees Celsius or 450 degrees Celsius accurately, respectively. Both of these temperature sensors will require you to modify the firmware to make sure that they accurately read these new high temperatures, and the documentation is adequately provided by E3D or Slice Engineering. For most 3D printing materials, the fumes are non-existent to negligible, but high temperature 3D printing brings a whole new set of considerations. PVC filament is highly toxic to breathe in, and you need some sort of filtration system to be able to filter out all of the microparticulate and the odors. BOFA fume extractors are the perfect solution for this problem because they have a lot of different form factors. You can have a very small one that sits right next to your 3D printer, or you can get a full-size cabinet one that you can use for your entire print farm. Peace of mind is hugely important with 3D printers, especially when you're going to start a print that you know is going to be overnight where you're not going to be able to be there to monitor it. The BlazeCut T-Series fire suppression system can help ease your mind when you're leaving it alone for long periods of time, because it is a passive fire suppression system. It's not something that needs a battery, it's not something that needs power. All you need to do is take the tubing, install it on the top of your enclosure or on your shelving system, and then as a fire grows, if your printer does catch fire, it will reach the tube and the pressure inside will cause it to burst and then put out the fire. We have tested this ourselves and seen it work beautifully. E3D has long been called the gold standard of hot ends, and now they have the gold edition to back it up. If you already have an E3D V6 or an E3D Titan AERO, these are both drop-in replacements, so you won't need to reprint any new mounts for the E3D V6 Gold Edition or the E3D Titan AERO Gold Edition. The heat sinks of both hot ends are gold anodized, which is just for flash, but to help show it off, the V6 comes with a clear fan duct that goes over the heat sink, whereas the E3D Titan AERO comes with a Noctua fan, which if you aren't familiar with that brand, they are virtually silent cooling fans. And to make things easy, the heater cartridge, thermistor, and the cooling fans all have quick disconnects, which makes it for really easy installation and changing parts out later if you need to. Most 3D printer users will upgrade their printers from a PTFE-lined hot end to an all-metal hot end, which will enable you to print as high as 300 degrees Celsius versus the 245 degrees Celsius of a PTFE-lined hot end. But for the power users, there's a step further with the MOSQUITO Magnum hot end or the E3D plated copper heater block. Now, respectively, you can heat up to 450 degrees Celsius or 500 degrees Celsius for those engineering-grade materials like Ultem, PEI, PEEK, PEKK, or to make printing polycarbonate just a little bit easier. Whether you're looking to upgrade the capabilities, the performance, or the quality of life with your 3D printer, these are some of the upgrades you might want to consider. To learn more about these upgrades, go to MatterHackers.com. I'm Alex from MatterHackers. Thanks for watching. Hey there, thanks for watching. I hope you enjoyed this video on the top 10 advanced upgrades for 3D printers and that you'll be putting one of these on your printers sometime soon. If you enjoyed videos like these, be sure to hit the subscribe button down below to stay tuned for all the others we'll be coming out with. See you on the next one.